today, even if she contacts me later, because she's missed 2 classes now and she's not even responding. Okay. All right. So number 8 needs to be reworded because it doesn't
Has nothing to do with 7.
Yeah, it has nothing to do with 7. We don't compute anything in 7. So I'll put that in the notes. Did you understand how to do the math?
Well, so that one I just put into SPSS and then pulled up the data, the T sample.
Okay, so let's
I
go
didn't do the math on that one. I just put it into SPSS and got the answer.
Right, but they want you to be able to compute it. That's one of the things that Tammy worked with me on. You have to be able, it's good that we can go into SPSS and it is right, but we have to be able to compute it if we can't put it in SPSS.
Okay, so then what, well, then that part I did not do. So what?
8 and 9, they wanted you to actually do the math, and then 10, A and B, they wanted you to check in SPSS.
Got it. Okay, because they were the same answers. So that
Right.
was, okay.
So the formula you're going to use is X bar plus or minus that T star times S over the square root of N.
So, okay.
That's the confidence interval for the T student sample.
Okay, so where's the other one? Okay, so let me see. The X bar is
In this case, it's 46.7333, and you get that. That's the mean from SPSS.
So you can put, you know how you put all 15 of those numbers in SPSS?
right. Let me go back to SPSS. Yes.
And that gives you your mean. That's where you're going to get your mean, and that's where you're going to get your sample deviation, the S.
Oh, so the mean was 46.733.
Yeah.
Okay, that's what I show on mine. Okay, and then the
T star they gave to you in the equation, it's the 2.1448.
okay, because that's the degrees of freedom.
That's the
Four.
T distribution.
Okay, and then
you times that by the S, which is also found in your SPSS. That's the standard deviation from the sample you entered data.
8.83.
8.82745.
Okay, 8.8. Oh, because we have to put all the numbers in before we round up.
And then the N is the 15 samples that he's using.
The sample size.
Okay. Okay. Once I have that, that would be very easy to calculate. So you would just do the plus and then the minus.
Yes.
And then you
yeah.
do that again for the 99%.
Yeah, and that gives you your intervals.
Right. Although where is the 95% come into this?
It's okay. So look on your SPSS.
Mm-hmm. Oh, and then I can change it under analyze.
Yeah.
Okay. Right.
But SPSS automatically does the 95%. So if it's 95, you don't have to go into the statistics box and change it. It's automatically there.
Right.
So if you look at your SPSS right under your mean, it'll say the 95% intervals.
Right. Yep. So then if I go into analyze and do it again, just change it to 99%.
In the statistics box after you hit explore.
And that changes your T-score. Really, that's the only thing it changes.
So when you're looking at the T-score, what do you guys see in SPSS? Because I'm seeing a 20.504.
Well, see, they gave you this 2.1448. Normally, you would have to take it out of SPSS, but they gave it to you.
Okay. Which is totally different from what I'm seeing.
Okay, so, oh, you know what? It doesn't give you the actual T-score in there. In number 9, they give you the new T-score.
Yeah, but do you see,
look?
Yeah,
but
but
that's the frustrating part is that in SPSS, their T-scores don't match what they give you or what they have in the videos.
right. And that's what was throwing me off is I wrote a question mark I got my T-score at 20.504. So I couldn't understand why he was getting a 2 point. I don't know. Is that what you guys got in your SPSS? Is the T score of 20?
Yeah, that's what it says. But then you go down to number 9 near the end, it says the T-score for a 99% confidence interval from the T distribution with 14 degrees of freedom is 2.9768. So we just use the T-score they give us.
Okay.
It does make it confusing though when things are not consistent and we don't know why.
Right.
So I can add that note too. I put a little thing in here that I need to put it, number 8 needs to be reworded, and then the T-scores in SPSS are not the same. Why?
Right.
And so maybe someone can answer that for us.
Okay. That's where I put a question mark next to those because I couldn't figure out the T-score and why that's why I just used the answer in SPSS because I got the right answer, but I wasn't getting the right T-score. So
The answer, interval answers are the same, but the T-score is not what they give.
Right. Okay. Well, this makes sense now. It was in the question and not.
Now,
We're using half the numbers out of our SPSS, and then we're using half the numbers out of the question. So, yeah.
so I did not even try the T-score formula here to see if the T-score that I got mathematically matches theirs or the SPSS. I didn't even try.
Well, it just doesn't make any sense.
Okay, so you get number 8 and 9 because it's
Yes.
just doing the math.
Yep.
Okay, and then 10 is checking the answers in SPSS. That was
Right.
all.
Yep. And I got both those.
So number 11 is just comparing them, and it's basically the same answer that we got from lesson. We're on 10, so it'd be whatever the last lesson was. Is that the bigger the number of confidence level is, the wider the range on this scale.
Right.
So you can do your null and alternative hypothesis, okay? Number 12A.
Yes.
Number 12B is
Yes.
figuring out the T-score. You did that one okay?
Yep.
And you get the degrees of freedom?
Yep.
-1 or n-1?
I'll take those every day.
Yeah, I like that.
No kidding.
Okay,
The
so
ones I had problem with was D and E.
okay, so let's go to D. Did you find
where's the P? Where's the P value?
okay, so did you find the T student distribution upload or download?
No.
Okay, it's in your, go to your textbook.
Okay. So that's another thing that we can download, like the applet.
Yes.
It's like the applet. They just
the
want
applet,
different way
only
to
it's
get to it.
T-score.
Okay. Okay, I'm in there. So let's see.
So just below the picture of the old guy who created this, there's 3 graphs.
Just below the picture of the old guy. Okay, hold on.
Like on the very first page or second page, there's a picture of an old guy.
Okay, there he is.
Okay, and then there's 3 graphs.
Right.
Just above that, it says click here.
Okay. Wait, just beneath the graphs, right?
Maybe beneath. I don't have my.
Oh, click here to show the outcomes for this lesson?
Yeah, so click here.
Oh, not the outcomes for this lesson.
No. Above, there's like a paragraph above those graphs. It says click here. At the very beginning of the paragraphs.
Okay.
Let me go to my manual so I can see.
Click here. Oh, okay. Yes.
So click on that.
Okay.
And then upload or download, whatever it's supposed to be. Download that and bookmark it so that you can access it because you'll need it.
Okay. Okay, so I have it. So for C, it says sketch the T distribution and shade the areas which represent the P value. So where do I find the P value?
So right under up at the top left-hand side, there's a little box that says degrees of freedom. Enter your degree of freedom, which is 14.
Where does it say 14? Oh,
Look
right
at-
there, right above. Okay,
Yeah.
C. Okay, I got it.
So in that little box, put 14 where it says degree of freedom, and then down below where the T is, where the Z used to be,
Right.
put the negative 117 in there.
Yeah, negative 0.117.
And where's that answer from?
That's from B. What T-score did you get for letter
Oh.
B?
Yeah, negative 118. Okay, that's the same thing.
Wait, you got 0.118?
It should be 117. He rounded in the video when he shouldn't have.
Oh, and that's what I did.
Changes the answer.
Okay, so negative 0.1.
Oh, it is 117. It is 117.
Okay.
Okay, so then because this is a two-sided equation, so you do both at the outsides.
Okay, I get the answer. Wait, 909. Okay.
Yep.
Well, there. That's so much easier. I couldn't figure out where he was getting the p-value. All right. I was looking on SPSS. I kept looking at that graph going, where is the p-score on SPSS? Okay.
Okay, so your score is 0.909.
Right. Okay.
It's greater than 0.05, so we fail to reject.
Okay, I got that. Oh, good. This makes it so much easier. See, this is why I need you guys.
Listen, this is why we all need each other. Holy cow.
Oh,
Let's do the quiz.
okay.
And Shelly helped me download the square root calculator so I don't have to mess with my calculator anymore.
Good.
And it's so much easier than figuring out the square root by hand.
No kidding.
Except that I always, when I had my calculator, I didn't always get the same answers. And so I was more comfortable doing it by hand and checking it on the calculator.
I have to do mine in sections on my calculator, or else I get a different answer.
There's ways to get around that, but I don't know. We learned it when we did our math 108. Shelly's daughter helped us learn the steps to not having to do separate things, but I don't remember that.
So this looks like we need the applet, right?
Yes,
Okay.
3 decimal places. Okay.
Okay.
Lessons, we had assumed the population standard deviation was known. In this lesson, we are making a different assumption about 0. What has changed? We assume 0 is unknown.
Right.
Yeah, I'd say first one.
Yep.
Okay, for the next 2 questions, let the null and alternative hypothesis be mu equals 8, and the mu is greater than 8. Assume that the population standard deviation is not known. Becca collects a sample size of 9 and computes the sample mean to be 11 and the sample deviation to be 6. So is sigma known? No.
No. It says so.
Okay. What is the value of 1? Or of t? Sorry, what is the value of t?
So we need to do the t deal.
Which is the
X bar minus mu divided by the sample deviation divided by the square root of the sample
That's
number.
the interval. The t equals something else. Let me find my note.
I think it's t equals.
No, that is how you find the t-score.
T equals X bar minus mu over. And I always
Yeah,
interrupt Shelly and I'm always wrong.
you're not always wrong. Okay, so we have.
Okay, so we have.
The X bar is going to be 11. And the mu is 8.
The x bar is 11. Oh, there we go. Yep. Wrote that
And the
down.
mu is 8. And then that's over the S, the sample deviation, which is 6, divided by the sample number.
Of 9.
Yep. And see what we get.
It'll be 3 over 2.
I got 0.00925. Is that what you guys got?
Well, 11 minus 8 is 3.
Yes.
Divided by the square root of 9 is 2. So it should equal 1.5, right?
That's what I have,
Okay,
1.5.
hold on. 6 divided by.
And sorry, I did that in my head. I didn't check the calculator.
That's
Gosh,
what I
you're
got.
Smart. Yep, 1.5.
It's just because those answers were super easy.
Oh, you are just way too smart.
Now it says round to 1 decimal point, so we can just put 1.5, yeah?
Yeah.
Right. Next question, 5 questions. Copy and paste them into your software. Use the null hypothesis that mu is 98.6. The alternative hypothesis is mu is less than 98.6 and level of significance is 0.05. Okay, so we have to open up a new data set then, I'm assuming.
They don't let me copy and paste. I'm going to have to enter them all by hand.
Me too. So I've got to write them down first.
But you can't copy and paste it? No, you cannot.
No, it's not letting you.
That's lovely.
Okay, so don't write them all down. We'll just read them out and enter them all together.
Okay.
I gotta get my thing uploaded first.
Okay, let me know when you're ready.
Okay, I'm ready, but I don't know if Shelley is.
I am.
Okay, I'll read them and I'll enter them. 98, 99.6, 97.8, 97.6, 98.7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 96.9, 98.8, 99.9, 96.8, 97, 98.7, 97.6, 98.7, 98.2,
Hold on, I got behind because I skipped one, so I'm having to go back here.
Okay, I'm going to start at the top and read them. And Katrina, as Shelley types, will you double check that
Yeah.
what I'm reading from my data set matches the quiz?
Yes.
98, 99.6, 97.8, 97.6, 98.7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 96.9, 98.8, 99.9. Shelley, where are you at? Are we at the 2 yet?
Yeah, you've cut, yes, go ahead.
Okay, I'm on 15, 96.8, 97, 98.7, 97.6,
Wait, did you say 97.6?
and 18 is 97.6,
Okay, got it.
98.7, 98.2.
Yep, that's right.
Okay,
There's 20?
yes.
Got
Okay,
it.
so the quiz is going to ask us, I'm going to write down this information here because I'll get lost. HO is mu equals 98.6. HA is mu is less than 98.6. And the significance is 0.05. Okay.
So first they want to know what the sample mean is.
So do we need to bring up the one sample t-test?
No, this is the mu first.
Oh, so that's,
The sample mean.
which is, how do you get to that?
Well, you do that.
Analyze, explore.
Okay, wait, explore.
The analyze descriptive thing explore.
Oh, there we go.
So I had 98.22 for the mean.
Yeah, they might want the 0 because it says 3 decimal places.
Okay, so 98.220.
Okay, hold on. 98.22. Okay, 98.220. Right. Okay.
Did you get, that's what
Yeah.
you got as well?
Yeah, my computer's just kind of slow. It just popped up.
Oh, what is the sample deviation?
Okay,
0.92201.
That's what I have.
okay, let me find that one. Where did you find that?
It's going to be
0.9
standard deviation.
0.922.
Because this is a sample test. So
It's
just
standard.
use the normal standard deviation that's given.
0.9220.
But they 3 decimal places, so it's 922.
Okay, next one. What is the t-score? Okay, so this is when we need to go up and use the, wait, the t-score. So do we take it out of there then, or do we have to go?
I'm gonna do it by hand to double check. You guys can
Yeah.
try to do the
Because the T-score has never been what we've worked it out to be.
You mean on the SPSS, it's never the same?
Right. So I'm going to do the mean, 98.220, our sample mean, minus the mu, which is 98.6.
right.
And then put that over the sample deviation, which is our standard deviation, 0.92201, divided by the square root of
20.
20. And that should give us our T-score.
Okay.
The top I got negative 0.38.
Uh-huh.
guys
Yes, I did.
The bottom I got 0.20616770359.
Yep, I got that too. So I got negative 1.843.
You guys call me fast. I'm just like still writing it down.
That's where I'm at. What did you get, Katrina?
Negative 1.843.
Yep, that's what I got.
Now it wants the p-value.
Did you get the same thing, Tammy?
Yes.
Okay. What is the p-value?
Okay, so is this the p-value? Then this is where we need to go into the software.
Right.
Yes.
This is
So now,
now, first of all, this is not a two-sided equation. We're less than, so we're only highlighting the far left.
but they had us open the normal probability applet.
Right.
That's not, if we're doing the T-score, shouldn't we be using the other applet?
Yes.
That's why I was wondering why they were having us pull up the other one.
What is the p-value? Oh, no. Go to the t-score. Negative 1.843.
So you take the t-score.
And because it's the negative number, you put it in the left-hand side. Because it's a
Okay.
one-sided equation, you put it on the left-hand side.
Right, okay, so we put negative 1.843,
And don't forget to enter your degree of freedom up there.
which
It's gonna
is,
be 19.
19, because it's S minus 1 or D.
right, okay.
And do we shade just the left?
I think so because it's less than.
Yeah. I got 0.1649.
I got 0.405.
I got 0.0 or
Wait a minute, my
0.04.
T-score changed. Hold on, my T-score changed on me.
Mine did too. I had to re-enter it.
Yeah, negative 1.843. Do this again. Here we go. Okay,
I got-
0.0405.
Yes, and they
How
want.
did you guys get that?
Okay, so your T-score should be negative 1.843.
Okay, oh, yes, okay. I didn't hit enter with my degree. Okay.
Oh.
Oh, okay,
Now double check your degree of freedom because when I entered my T-score, my freedom changed.
mine did too. Okay, I couldn't figure that out. Okay,
So we must have to enter the T-score before we enter the degree of freedom.
Probably.
and then we have
Okay.
to round up, so 0 or 0.041.
Yes.
Okay, what is the correct decision based on this evidence? Okay, so now we need to compare to,
So if our p-value is we're looking at the p-value, comparing that to,
Our A, which is 0.5. So we are 0.5
so we are, so
or
we
1,
would.
so it's less. So we
So-
reject the null.
Reject the null because it's less.
Right.
yep. Okay, oh my goodness gracious. There's another whole set of
My
numbers.
is having a meltdown. Just
Oh my gosh. All right, let's go back in.
we backed out of the house, Shelley.
Why?
Mold, plumbing, new roof,
They-
no garage.
They won't, they won't fix it?
Well, the problem is that we have to have all of our ducks in a row by Tuesday. We're going out of town today. We don't have time to get our ducks in a row. So
Oh,
we would be stuck with the house as is. And so we're not going to do that. So if it's still available when we come back, then we'll put in a
Right.
new offer.
Gotcha.
If it's gone, then it wasn't meant. Okay. Use the phone. Sorry, my coffee, guys. I've been on my meds for 72 hours. I should be done with this cough, right?
oh, awful.
Yeah.
Okay, so use the following values, which were pulled from the data of baby boom. These values are in wait time and minutes between Bursar Hospital. Copy and paste them into SPSS. Oh, I hate it when they do that. Can we just bring up the baby boom file?
Is there a baby boom file?
Yes. I'll go there.
wonder-
And,
If there was a file for the other one too?
was there?
I don't know, but I'm wondering,
Well, I wish we could just copy and paste.
right? Exactly. Okay, let's see here.
I know there's a baby boom file because we've used it before in something.
Okay, there is. I'm gonna pull up the numbers. Okay, what numbers do they have though?
For what?
What's the first number?
59, 14, 37, 62, 68, 2, 15, 9, 157, 27, 37, 2, 55,
Okay, it's the wait time.
86, 14, 4, 40, 36, 47, 9, 61.
Oh, wait a minute. Maybe not.
Do you want to read those to me one more time? I'm going to manually put it in.
Okay.
Okay,
Are you ready?
Yeah.
59,
Uh-huh.
14, 37, 62, 68, 2. Hang on, my thing just covered it up. 15, 9, 157, 27,
Wait, 157?
157,
Okay.
27, 37, 2, 55, 86, 14, 4, 40, 36, 47, 9, and 61. Are those?
Yeah. They are, but they add a whole nother list of numbers. That's not all. They have a bunch more after that.
Oh, so we need to come up with our own values then.
We do need to put this in ourselves.
Okay, down to 60. So just copy it off the SPSS, Shelley, down to 61.
Down to number
Oh.
down to number 21.
22.
Oh, I only have 21.
Oh, then you're missing something.
It's because
59, 59, 14, 37, 62, 68, 2, 15, 9, 157, 27, 37, 255.
oh wait, are you saying number? It's 2 by itself, or is it 255?
2 is by itself.
Okay.
2 and then 15, 1, 5, not 55.
Oh, 1, 5. Okay. And then go ahead.
9, 157, 27, 37, 2. Oh, there's another 55 after that one now. Sorry.
Oh, hold on.
Wait, there's what?
Number 13 is number 2 all by itself, and then number 14 is 55. So I totally messed you up.
I think I'm off anyways because I'm only on 13. Is it because I don't have a?
13 is number 2.
I have 55 as number 2.
55 is number 14.
Oh, that's not what I have. Hold on.
Okay, you guys go to SPSS and copy down the wait times 1 through 22.
That's what I did.
Okay.
Mhm. 55, 86.
There's only a total of 21 numbers.
Okay, hang on.
Which would give us the N.
All right, let me finish this and then I will read them off and we can find out where we're off.
SPS is right down to the last number of 61. I just double checked them.
So
Which
yes,
means
there is
that-
21 numbers.
Yes, so which means that you should have 21 numbers.
So in SPSS, they might have started on line 2 or something.
Right. That's what
They did. They did start on line 2 in SPSS.
Okay.
They didn't start on the first one.
Okay, I have all the right numbers in here.
All right.
Okay, so we want a level of confidence to be 01.
Okay, so that's where you go into the compare means
Just a
and
second.
go to the one sample test, and then instead of 95%, it's going to be 99.
Wait, what are we doing?
Is that right? When we pull up the one sample t-test, we have to change it from 95% to 99%.
Why are we changing it? Did it say to change that?
Well, because it has to be at a 0.01 instead of a 0.05.
Yeah, we change it to 99%.
Okay.
Then we need to go to,
Go to analyze, descriptives, explore.
I just went to analyze and went right to oh gosh, let me go back. Analyze down to compare means, and then over to the one sample t-test.
No, go to analyze,
Okay.
descriptives, explore.
Okay.
Move your variation over. hit the statistics button and change that one to 99.
Okay.
All right.
Okay.
So now you need to copy down the information here. You need the 40, the mean, which is 40.0476. You need the standard deviation of 36.35. Maybe you don't need that one actually.
Well, if we're trying to figure out the p-value, we do, because we got to get the t-score to do the p-value.
Okay.
So the standard deviation is 36.35585.
Yeah.
Yes, and then the degree of freedom will be 20.
Now where's that? Where's the
And then
degree?
under the number is 21.
Oh, minus the 1. Okay.
Freedom is 20. I think that's all we need for that formula, right?
Yeah. So you're going to put 40.0476 minus 40 on the top. And then 36.35585 divided by the square root of 21 on the bottom.
Sorry.
I got 0.0476 for the top. Is that what you guys got?
Yeah, it's just minus the 40.
And I got 7.933496887474 for the bottom.
What did you get? 7.9?
33496887474.
That's what I got. So negative 0.0599.
Almost there.
Oh, I didn't get a negative.
I didn't get a negative either.
Oh, I don't know why I put that negative in. You're right.
0.0059998763. So we'd have what, 0.006?
Just 0.06.
How do you get zeros? I have a 00.
I get 0, 0 also.
Okay, let me re-enter this. 1.9. I got 0.05999.
I get 0.00.
That's what I have.
In 0.0476 divided by 7.9.
Oh, you know what? I think I'm missing a 0.
And this is two-sided, so don't forget to highlight both sides.
Oh, you're right. Okay, so 0.0059. So that would just be 0.006. Okay.
So now are we putting this to the right in the student's T probability?
Two-sided, both sides.
So
The two-sided equation. So p-value equals 0.9953.
because the degrees would be 20.
Yep,
And then the t-score would be the 0.006.
yep.
Yep.
So 0.9953.
They want 3 decimal places, so I would imagine we just put 0.995.
Right.
Okay.
That's for number 11, 0.995.
So if it's 0.995 and the degree of significance is 0, then it's greater than.
Yeah, so we failed to
Fail
reject.
to reject.
Okay.
Okay, you decide to try another alternative hypothesis. This time you use U equals 40, and you keep the same level of significance. Did the p-value increase or decrease?
Oh, because the other one was just different. It wasn't greater. So that was a two-sided. This is a one-sided.
Right,
So-
so we just have to go back and take out the less than.
So this one is mu is less than, so this time we just go to the
Right,
T and only do the left. Because M is less than 40 in the HA.
Right, so we go to the probability applet and just put 0.006 and shade the left side.
Right,
And I have 0.4976.
right. Did
Right.
you understand that, Katrina?
Yeah. Yep,
So we still keep the fail to reject.
But it's asking, does it decrease or did the p-value increase or decrease?
Oh, decrease. We probably
Decrease.
didn't have to do that to know, but
it decreased.
So what decision do you make? We
fail
still-
to reject.
Yeah,
Right.
it's still greater than.
So fail to reject, yes.
Now construct a 95% confidence interval for the true mean wait time between births at a hospital. So we need to go in,
Now we need to just go back to,
Use
What-
SPSS and change it to 95 instead of 99.
because it says, so 15 is what is the lower limit of this confidence interval? And then, and so we need to know the lower and the upper.
Okay, so do you know how to do that, Katrina?
yeah, I'm changing it from 99 to 95.
Right.
And I'm pulling that up, and they just need to know the lower and upper, right?
Right, so the lower is 23.4986 and the upper is 56.5966. Is that what everybody else got?
Hold
That's
on,
what I got.
I'm still getting there, so just a second.
Yeah, I did get the same thing as you.
Okay.
497.
Okay, lower bound 23.4986.
Yes.
Or
49. So it'd be 499.
because they want the 3.
Well, it's
Okay.
saying, this one says round to 1 decimal place.
Oh,
Oh,
So 23.4.
23.5.
No, it would be 4 because it's 23. Oh, yes, because of the 9. Yes, 23.5.
and then we need the upper, which is 56.59. So what, 56.6?
56.6.
Are you ready to submit?
Yes, let's go for it.
Please be
100%.
100. How do you do that so
We
fast?
got it.
Woo!
Yay.
Okay.
Did it.
Okay, so we are done. I'm going to turn off the broadcast and we can ask questions.